Hello, hello. So I have another bit of kit on my bench this week. This is a Heathkit transistor tester. It's the IM-36. So I got it from eBay. I've been wanting one for a while, but I haven't found one that had like all the bits and bobs that are easily lost at kind of a price range that I was willing to accept. But this one came across. It was a little bit grimy, but I took all the knobs off. I gave it a bit of a wipe down. I've been in the process of restoring it. There's a little bit of like some rust on the back panel, but I can deal with that at a later date. But lately I've just been testing all the functionality of it and making sure everything's in spec. Everything's more or less fine except for the voltage ranges. I'm having issues with 7.5 and 9 volts. So how this guy works, just kind of a brief overview, is these voltage ranges stem from it having D cells in the back. So the voltage range goes from 1.5, which would be the voltage of a single cell, all the way up to 9, which would be selected in 1.5 volt increments. So there's like little voltage tap wires that go to each battery, and that's how it gets the various ranges. It puts them in series. But let me kind of demo you the issue I've been having. And I have a couple meters out here just for sanity's sake, so we know the voltage we're seeing on this little dial is accurate and reflects the real voltage. So let's just go down the line. So this first range is read on the 15 scale. It's 1.5 volts, should just be one cell. So let's turn on the voltage here, and it's reading a little bit over. It's a little bit over 1.5, and that's what we see on the meters. So it's at 1.5, 1.6, somewhere in that range. So that's kind of accurate on this little dial. Let's move up to 3 volts, which this little silk screen with a 5 on it means that we're going to be reading that 3 volts on this lower scale. So let's give that voltage. And we see on this lower scale, it's a little bit above 3 volts, which our meters also confirm. 3.2-ish seems, accurate enough for the little vernier placement of the needle. 4.5 is also a good range. We're reading it on the lower scale yet again. Give it some voltage. And we're reading very high, so a little bit after 4.5, like 4.7, 4.8. And we are getting just about that on the meters. So again, the scale here is reading accurate voltage, true to what it's putting across the terminals. 6 volts is also fine, but you can see that it wants us to read it from that 15 scale again because it's within this little bracket. So we're going back to this top scale. I'm gonna give it voltage. And you see there it's above 5, which is around 6. So 6.4,15, near enough. The problem starts being introduced when we try the 7.5 and the 9 scales, which are both read on that 15 scale here. I'm gonna give it voltage. And look, we're at 5 volts on the 7.5 scale. And, that's literally 5 volts. That's what I'm measuring on all my meters, and that's what's being reflected here. 9 volts isn't any better. So there's 9 volts. I'm gonna give it some voltage. And it's again at 5 volts. So I have a theory. I don't know if it's correct, but I'm guessing since there are voltage tap wires that go from battery to battery, causing them to be in series, when it gets to a certain cross point and it disengages this point and makes this point active, just for a visualization, I think there's a corroded terminal or something that has high resistance or something that's not letting that voltage pass like unimpeded. And then when you go back up to the range to 9, there's still that dodgy path in the series line. So I think maybe something like that is going on. So I'm gonna have a look in the battery terminals. They're very corroded, so I'm gonna measure them and make sure that the resistances from the terminal to the spring is actually low enough to what you'd expect. But also, these terminals here, the ones we're measuring against, have capacitors across them. I'm gonna double check that those capacitors are good. They're the only 2 capacitors in this unit. So I'm going to remove them, measure them, maybe replace them and see if that makes the issue go away. All right, so I knew this going in when I bought this, that there was some leakage happening, and it's pretty bad. I figured I could brush it up, sand it up, and it'd be pretty much good to go, but some of these springs, for example, have a bunch of corrosion on them, and they're tied down to these little screw terminals. And I mean, it's pretty secure, and there's little, you know, insulating spacers so they're not grounded out against the metal chassis. But I think this is probably where my issue is, especially since it's just on a few ranges, so I'm guessing it's just a few terminals. And also especially that I think this terminal up here is the positive rail, and when it taps off, it taps like this. It goes in sequence downwards. So I'm gonna focus my area on this side because I think this is more or less good. This is the terminal that is continuity with these pegs, these power pegs. So I think that's where the voltage divider network switching starts. So like, it should be this battery when it's on 1.2, it should be this other battery when it's on 3, 4.5, and so on to back here. I guess I can maybe try to measure that that's true by putting the batteries back in and doing some measurements. So let me get those back in and kind of do that. All right, so I put batteries back in, and forgive the crudity of my camera setup here. I needed my hands free to be able to probe through all this. So I have the positive lead hooked up to one of the positive input voltage terminals, and I have confirmed the fact that this battery terminal up here is continuous, it's connected to all of these positive inputs. So I can beep that out with my continuity range meter, and we know that this is the voltage common point, which is the positive input. And when you select your different voltage ranges, the ground moves from this tap to this tap to this tap to this tap, and so on. So the 1.5 volt range is this battery alone. The 3 range is this battery plus this battery. The 4.5 would be these 3 batteries, and then so on down the line. I'm having issues in this area because the 7.5 battery should be this one, and the 9 volt battery should be this one. So I'm gonna do some measurements. I'm gonna test the voltage. I'm gonna select the range on my meter back to voltage, and we're just gonna test voltage points. So I have my ground lead. We're gonna hook it up to this ground over here, which I have 1.6. That's right for a single fully charged cell. I'm gonna move it up here. We have 3.2. That's more or less what we were getting on our other meter measurement. This should be like 4.8. Yeah, it was a little bit high because these, you know, 1.6 cells are reading on the ranges as 1.5. So those 0.01s will add up and add up and add up. So that's why it's reading a little bit high there. This next one should be our 6 volt range, which again, it's reading a little bit high. But once we start getting down to this voltage point, that's where things start getting very squirrely. And like that one as well, if I go even further down to the 9 volt range, it's more or less starting off at 9, but then it's kind of drooped down to 7. So I think the failure point has to be this terminal here, because I can measure here just fine. It's 6.4, that's what you expect. And then the tap that touches this ground over here, I can just touch that. And I don't know why that's reading 8 volts all of a sudden, but it shouldn't. It absolutely shouldn't. That should be the 7.5 volt range. And then this should be the 9 volt range over here, which it's squirrely yet again. So I'm guessing that since it's intermittent, I'm getting different readings for different times in which I'm probing it. And the fact that it's consistently changing from this battery and onwards being consistent, and this battery being very inconsistent, I think that this point right here has just too much corrosion on it. And let's change the camera angle yet again and do some measurements with resistance. All right, so I hope this is a bit of a better angle. These are some of the battery terminals we're going to be measuring, and I have my meter in ohms range. So I basically think that this terminal, whether this terminal itself is the issue or something connected to the terminal, is our problem point. That's what I suspect, just because these two batteries associated with those bad ranges are over here, and that is probably the point of failure, because everything beyond this point works. Everything beyond this point does not work, or works relatively crappily. So I'm gonna do some measuring. I believe that this point and this point are shorted together. They are. So these are the points in which the battery is connected underneath the chassis. I'm also going to measure these 2 points up here. We find that screw terminal there, touch the spring, and that's low ohms as well. There's a bit of resistance because it's a metal wire that's connecting the two, as well as there's a bit of surface corrosion that I'm digging through to even get that measurement. But the next one is, I believe, these two are connected. So let me measure these two. And I'm getting like 2 megs. So whatever corrosion is on this terminal here is causing it to where this is a huge resistance. It's a giant resistance. So that's 1 meg, 2 megs. So I think that this is our problem terminal. This is the last terminal in line. So that would have gone to, I don't know, whatever ground point is on that range. But I think literally this spring is our issue. So I'm gonna just measure the resistance of the spring. So I'm gonna purchase my probe on the bottom of the spring, put my probe on the top of it. And my meter's kind of all over the shop. So that indicates there might be an issue there. I'm gonna maybe get my probe purchased on this screw terminal that's actually screwing it to the chassis. Maybe that's a better purchase point. Just maybe digs through some of that corrosion a bit by wiggling back and forth and then measuring it again. No, it's still like 15 ohms sometimes. It'll read 2 ohms. So this spring, I think I just need to remove, clean up this screw, and get all this corrosion out from everything, and it should be hunky-dory. I should have a working bit of kit after that. All right, so I have the battery terminal, that screw peg, the insulator washer, all off of the position it was in the chassis. There's a lot of rust up in here. I probably just have to sand that away. I don't think it's affecting the issue much. I did happen to measure these 2 points, and they are fine. They're like 0.1 ohms or whatever. So that's definitely not the issue. I really think it's these components here. So I'm gonna sand off as much corrosion as I can to get a better contact point and see if that solves the issue. Otherwise, we'll be looking towards those capacitors, which at this point, I don't think is the case. I think we found the culprit here, but I'm gonna do a bit of sanding and we'll come back. All right, so let's get this guy back together. I've sanded the mating surfaces between this spring and this terminal screw, and hopefully that should be contact enough to where you get full continuity and these voltage ranges will be working. So I got the spacer, the screw, the terminal kind of all together. I'm gonna kind of try to get this finagled in to the unit. It's a bit of a weird setup and a weird angle. I will try to get it in there. All right, so quickly before I put these remaining batteries in, I did a quick resistance test on these 2 points that were giving us issues before, and we're getting what we expect. Very low ohms, pretty much shorted out. So this terminal versus this terminal. These are the terminals that were giving us like 20 megs or 2 megs or whatever the hell it was before. This has given me confidence that these ranges are fixed. So I'm gonna get batteries in here. We'll get it all hooked up and we'll test the ranges for once and for all. All right, so I guess moment of truth. I have all this stuff hooked up. We're gonna be going through these voltage ranges again. The 7.5 and 9 volt ranges should hopefully be fixed. So I guess let's just quickly go through the ranges again. We have 1.5, it's reading a little bit over, so 1.6. We can assume all these cells are 1.6 each, so it's gonna be in increments of 1.6. So we have 1.6, we got the 3 range, which is like 3.2. We're reading on the bottom scale, it's a little bit over that 30, so that's 3.2. The 4.5 volt range is like 4.8-ish, something like that, 4.8. The 6 volt range was working before. That should be like 6.4, I believe. So we're a little bit above the 6 position. We're 6.4. And here's the moment of truth. Now, we're on the 7.5 range. I'm about to give it voltage, but just to kind of make a little bit more of a drum roll and an anticipation, let's try to figure out what voltage we expect, because it's not going to be 7.5. I'm going to go to my calculator over here. Let's go ahead and clear it out. I'm going to say 1.6 volts per cell, and we're going to multiply that by how many ranges? So 1.5, 3, 4.5, 6, 7.5. So this should be 1.6 times 5 multiplied by 5. We should get 8 volts. So on this range, we're expecting 8 volts. Let's go ahead and make sure it's 7.5, give it voltage. Bum, 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 bum. We're on this top scale. We got 5, 6, 7, 8. And on the meter, we have 8 volts. So that's fantastic news. This has actually been fixed. And we can verify that by going to the last range in which it was giving an issue. Give it voltage, and we're at a little bit above 9 volts on the scale there, which we're at about 9.7. I believe 1.6 times 6 would be 9.6, but it's near enough. It's a little bit above voltage. Those voltages do accumulate when you put them in series, just because these cells are fully charged. But I'm happy with how this turned out. It was a relatively easy fix, and thanks for joining me. It was a fun kind of introduction into how you might troubleshoot some of this old gear that is in relatively good nick, but might just need a little bit of love and care. Well, take care. Have a good day.